Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the TEAS. We have been solving math problems out of this book here, the study manuals for the TEAS. If you do not own this book already, purchase one immediately. You're going to need it. The problems that we are about to solve are the ones that you will find on page number 58. Please turn to it. Page number 56 rather, not 58. I don't know why I said 58. Page number 56, and today is our lesson number 4. Let's take a look at them. These problems that we are about to do deal with the concept of adding and subtracting fractions. Let's listen, before we start out with the example that we see on that page there, on page number 56, let's start out with something very simple, something very basic. For example, how much is half plus a quarter? Well, as you can see, a half plus a quarter, because they have the different denominators, we can't really add the top part. We can only add the top part as long as the bottom part is the same. Do you understand? In this course, we're going to keep things very simple. Things that top part and bottom part, they're not numerator and denominators. Do you understand? So as long as the bottom is the same, we can add the top. How do we make the bottom? How do we make the bottom of this fraction same as that one? Well, it's very simple. Multiply this fraction by 1. But you multiply it by 1 in a clever way. Multiply it by 2 over 2. When you multiply something at 2 over 2, 2 over 2 is 1. If you multiply something by 1, it doesn't change the value. So now we have 2 times 2 at the bottom, and on the top we have 2 times 1, which is 2. So we get 2 over 4, which makes perfect sense because everybody knows that half is made up of 2 quarters plus another quarter. And what do you know? A 2 quarter and another quarter make 3 quarter, which we already knew from all along, which we knew from the very beginning, that a half plus a quarter equals 3 quarter. A half plus another quarter will make it 3 quarter. But as you can see, we have to make the denominator the same. The same exact thing is going to go on with every single problem here. So let's get going. As long as you when you have a fraction, as long as you multiply the top and the bottom by the same number, it does not change the value of the fraction. The fraction is still the same because you're multiplying the top and bottom by the same number, you're essentially multiplying it by 1. When you multiply something by 1, it's not going to change its value, obviously. Let's do the very first one. We have 1/4 plus 1/6. Again, keep it very simple. Ask yourself, how can we make the bottom the same? Well, it's very simple. Take this fraction and multiply the top and the bottom by 6. And take this one and multiply it top and bottom by 4. Why by 4? Because we have a 4 here. So now we got 6 times 4 over here. Here we got 6 times 4. They have the same denominator. And on the top we have 6 times 1, which is 6. And the bottom is 24. And here the bottom is 24. So because they have the same denominator, we can add the top. It's just 1 times 4, which is... So we end up with 10. 6 plus 4 is 10 over 24. And then all you have to do now is reduce it. That's all. Divide top and bottom by 2. We get 5 over 12. The answer is 5/12. The answer is 5/12. So that was the example that they do there, and now let's do the practice problem. Number one. Practice questions. The very first one says 2/3 plus 5/12. Now keep in mind that if there is any way at all that you can reduce the fraction before you begin the process of adding and subtracting, you must reduce it. Here we have 2/3 which cannot be reduced, we have 5/12 which cannot be reduced, so now we have to somehow figure out a way to make the denominator the same. Here we have a 3. 3 times what number is going to give us 12? Well, 3 times 4. So there you go. Multiply the top and the bottom by the 4. And now this fraction has a denominator of 12, same as that one. So here we get 4 times 2, which is 8. 8 over 12 plus 5 over 12, which is going to give us 13 over 12, okay, keep listening, 13 over 12, which can be written as 12 over 12 plus a 1 over 12. Nobody's going to argue with that. 12 plus a 1 12 is going to give us 13 12. 12 over 12 is simply 1. 12 over 12 is simply 1. So we end up with 1 plus 1 over 112, which is simply 1 and 112. The answer finally is 1 and 112. Let's do the next one, number 2. Number 2. Number 2 says simplify the expression that is 3/8 plus a 5/6. 3/8 plus a 5/6. I shouldn't have made it so crowded. I'm writing way over there because I didn't want to erase this thing. We don't need this anymore, right? We are done with it. Number 2. 3/8 plus 5/6. Again, keep it very simple. Don't waste your time trying to figure out the least common denominator and all that. Sometimes it is essential, sometimes it is necessary, and you cannot do without it. Most of the times you can just get away without having to figure out the least common denominator, as long as you can find out any freaking common denominator. It doesn't have to be the least one. So if you are looking for any denominator that is common, any denominator that is same here and here, the simplest and the easiest way to do this thing is take this one and multiply it by 6 over 6, and take this one and multiply it by, take this one here and multiply it by 6 over 6, and take this one and multiply it by 8 over 8. So now we got 6 times 8, 6 times 8. There you go. So in the top we have 6 times 3, which is 18, and in the bottom we have 6 times 8. 6 8s are, how much are 6 8s? 8 5s are 40, 48. And this is 40. In case you are not familiar with the language, the way I speak here, what I said was 8 5s are 40. This is how we speak in the desert. 8 5s are 40. So here we have 48, here we have 48, we have the common denominator. All we have to do now is to add up the top. 18 plus 40 is going to give us 58. So we end up with 58 over 48. 58 over 48 can be written as 48 over 48 plus 10 over 48 plus 10 over 48. And 48 over 48 is just 1, so we get 1 plus 10 over 48. And 10 over 48 can be reduced here because they are both even numbers. We can divide the top and bottom by 2. So we end up with 5, and here we end up with 24. 1 plus 5 24 is same as 1 and 5 24. 1 and 5 24, which is the same answer as what we have here. But the key here is to be able to do this thing in the exam with speed. As I reminded you many times in the first 3 days, nothing that we're going to do here is earth-shattering, nothing that we're going to do here is complicated, nothing that we're going to do here is mind-boggling. It is a very, very simple elementary math that you learned many, many moons ago in your school years. You just have to refresh your memory and train yourself to be able to do this thing fast. Because these days, of course, everybody depends on the calculator. Why in the world would you sit there and try to figure out the freaking addition of these two fractions? There is no reason for it. Let's do the next one, shall we? What number was this? 3/8 plus 5/8, that was number 2. Let's do number 3. Number 3 says 3/15. Is that right? No. 3 minus 5 and 1/3. This is number 3. The very first thing we have to figure out here is what this 5 and 1/3 is. This is called a mixed fraction. What is it in improper fraction? 5 and 1/3. In case you are not familiar with the terminology, let's go through them one more time very quickly here. Or not one more time, we have never done it. This is called mixed fraction, which of course is same as 2 times 1 plus 3. 1 and 1/2 is same as 3 halves. And this is called improper fraction. Now the reason why it's called improper is called improper because the top is more than the bottom. In other words, this thing is something more than 1. That's why it's called improper fraction. A proper fraction is where top is less than the bottom. This is called the proper fraction. So let's convert this thing. 5 and 1/3 is same as 5 plus a third. The question is, how can we write 5? How can we express 5 so that we have 3 at the bottom? Well, that's very straightforward. Let's not write this as 5. Let's write that as 15 over 3. 15 divided by 3 is 5, isn't it? So there is your 5. 5 is right here, 15 over 3. And here's your third. So we have 15 third plus a 1/3, which is 16 third. Which makes perfect sense because what we are taught in the school year is that when you have something like this, you multiply 5 times 3, which is what this part is. That gives you 15, and then we add 1, which is exactly what that is. 5 times 3 is 15 plus 1, which is exactly what we 15 plus 1 ends up at 16 and a third. So that has to be written as 16 and a third. Now how can we express this 3 so that it has a denominator of 3? Well, 3 can be expressed as 9 divided by 3. 9 divided by 3 is 3. So now this one has a denominator of 3, this guy has a denominator of 3 because they have the same denominator. All we have to do is subtract the top. So we end up with 9 minus 16 over 3. As you can see, 16 is more than 9. We're going to end up with a negative answer. It's going to be negative 7 over 3, which makes me nervous because I don't recall having a negative number. Oh, it is negative 7 over 3. We're not quite done yet. This is an improper fraction because 7 is more than 3. The top is more than the bottom. When you have an improper fraction, the convention dictates that we write this as a mixed fraction. So let's continue our journey. 7 over 3 can be written as negative 6 over 3 and a negative 1 over 3. You see, negative 6 and a negative 1 is going to give us negative 7. 6 over 3, as we know, 6 over 3 we know is negative 2. So it's negative 2 and a negative 1/3. A negative 2 and a negative 1/3 is same as saying negative 2 and 1/3. Negative 2 and 1/3. What number was this? This was number 3, I believe. Let's go on then. Number 4. We are done with this one. Number 4. Number 4 says 3/15 3/15 minus 2/25 minus 2/25. And now as I reminded you just a little while ago, if you have a fraction which can be reduced, reduce the fraction if you can before you begin your work of adding and subtraction. It makes the life easier. It also makes it life easier to figure out the common denominator. Because otherwise here, we're going to end up having to multiply this thing by 25 over 25 and having to multiply this thing by 15 over 15. We're going to end up with a very large numbers. It's a waste of time. Reduce it. Divide the top and the bottom by 3. So this 3 drops out and becomes 1 and 15 becomes 5. So what we have here is 1 over 5 minus 2 over 25. Now how can we convert that 5 into a 25? Well, multiply the top and the bottom by 5. There you go, we're done. Now this guy has a denominator of 25. So does this guy. Because they have the same denominator, they have the common denominator. All we have to do is 5 times 1, which is 5, minus 2, which is 3. We end up with a final answer of 3 over 25. That's it, 3 over 25. That's it. That was the end of that question. What I'm going to do right now actually is not part of the deal. It's not in the book. They're not asking for it, but they will eventually down the road, they will ask us about the percentages. My question to you is this, okay? Listen carefully. If you had to express this number, in percentage, express this quantity, express in percentage, will you be able to do this quickly within seconds? And when I say within seconds, like that. Let's find out, shall we? Let's find out. 3 over 25 is what we're dealing with. 3 over 25. Where should we write this thing? I need the room. What does the word percent actually mean? Literally mean percent. What does the word actually mean? What is the literal meaning of the word percent? Percent literally means what exactly it says. What it exactly says, which is per 100. Cent is where your word century comes from. Per 100. Percent means per 100 or over 100. If someone says 7%, 7% is 7 over 100. If someone says 37%, 37% is 37 over 100. 12% is 12 over 100. 50% is just 50 over 100. You get the idea. Somehow, if you can convert this bottom into a 100, we can figure out what percentage this quantity is. 3 over 25, we can figure out what that is in percentage. If you can somehow figure out if you can somehow convert the bottom part, the denominator, into a 100, how can we convert 25 into 100? Well, that's very straightforward. Multiply it by 4. Multiply the top and the bottom by 4. Voila! Now we get 25 times 4, which is 100. And on the top we simply have 3 times 12, which is 3 times 4, which is 12. So it turns out that 3/25 is equal to 12%. Is equal to 12%. Let's do a few more, shall we? Let's do a few more for fun. See if you can figure out. And if you want to pause the video every time, that's actually, I think, is a great idea. As soon as I put something on the blackboard, hit the pause button, ask yourself what is this in percentage, figure it out yourself before you continue it. You'll learn more that way. Here's the next one for you. Here's the next one. Remember, somehow your job is to convert the bottom into 100 or as close to 100 as you can. It does not have to be exactly 100. It has to be as close to 100 as possible, because what you have to understand is that this exam is a multiple choice exam. You don't have to be so freaking precise. If you're close enough, that's good enough. So if you get as close to 100 as possible, and that's your approximate percentage. That's what you just want to get a ballpark idea so that you can figure out what the wrong answers are. That's all. For example, if somebody were to ask us how much is 7 divided by 33 in percentage, well, 7 divided by 33, we want to convert the bottom into 100 or something as close to 100 as possible. Well, we can convert 33 into something very close to 100 simply by multiplying the top and the bottom by 3. And now we have it. 33 times 3 is 99. So on the top we get 7 times 3, which is 21 over 99. 21 over 99 is not exactly with 21%, but it's pretty damn close to it. It's approximately 21%. Nobody's going to argue with that. Let's do one more, shall we? Here's another one. How much is 8 over 11 in percentage? Can you express 8 over 11 into percentage very quickly, within seconds, as I said? Within 2 seconds. It should take no more than 3, 4, 5 seconds at the very most. How do we convert 11 into something very close to 100? Multiply top and bottom by 9. If we multiply top and bottom by 9, we get 11 times 9 again. That again is 99. That again is 99. What is the top part? 8 9s are 72. How do I know 8 9s are 72? Because I know that 8 10s are 80. 8 9s are, here, 8 9s are 72. Why? Because 8 10s, if you have 8 10s, 1 10, 2 10, 3 10, so forth, if you have 8 of them, well, 8 10s are 80. So 8 9 must be 8 less than that, which is 72. There you go, that's it. So it's approximately 72%. Turns out that 8 9 is approximately 72%. Let's do one more, shall we? The next one I have on the list is a little bit tricky. It's a little bit tricky. I'm going to erase all this thing, we don't need it. Let's do one more. Two-seventh. How can we bring 2/7 close to 100 as possible? Well, since we want to go all the way to 100, the good starting point would be 70. 70 represents 10 sevens, and then after that just keep adding 7 until you get to something very close to 100. That's all. If you add one more 7, that's going to be 77, which represents 11 7. Add one more 7, which will give you 4 and 8. It's 84. That's not still close enough. Let's add one more 7. We get 1 and 91. Then add one more, and then we get 98. Voila. Of course, in reality, in the real exam, we wouldn't be so damn silly to do it out individually like this. Ask yourself, it's very simple. 70 represents 10 sevens, and then 4 sevens are 28. 4 sevens. 4 sevens are 28. Everybody knows that. So 28 plus a 70 is going to give us 98. So here we have 10 sevens, and here we have 4 sevens. 10 7 plus 4 7 makes 14 sevens, which means we have to multiply the top and the bottom by 14. But you have to be able to figure this out very quickly. That's it. The bottom is equal to 98. We already know that. And the top is going to be 2 times 14, which is 28. So it turns out that 2 7 is approximately equal to 28%. 2 7, it turns out, is approximately equal to 28%. Let's do one more. This thing is getting too ugly. I'm going to rewrite it. 2 7 was it was. We multiply the top and the bottom by 14, and that comes out to be. So what we find is that 2 7 is approximately equal to 28%, because it's 28 out of 98, multiplying by 14. Let's do one more, shall we? The next one we have is 5/8. Let's do 5/8 separately. I think 5/8 deserves, maybe we can do it here. 5/8 is a tricky one. Well, not a tricky one, but it's a special one. There are two ways we can go about it. One way is actually figure out the exact value of 5/8 in percentage, which is not actually as bad as you might think. 5/8, if you think about it, should be same as 4/8 plus an 8. 4/8 plus an 8. How much is an 8 in percentage? You should know this. Let's do it here. We know 1/4 is 25%. If you take half of that, half of 1/4, 1 times 1 is 1, and 2 times 4 is 8. Half of 1/8 is, half of 1/4 is 1/8, and since we took a half of this side, we have to take a half of that side. And what is half of 25? Half of 25 is 12.5. Turns out that 1/8 is exactly 12.5%, 12.5%. So 4/8 is just half. So that's 50%, and 50%, and this is 12.5%. So it turns out 50 plus 12.5% is exactly 62.5%. Turns out 5/8 is exactly 62.5%. Now we're going to do the method that we've been doing, which is to bring the bottom as close to 100 as possible and see what we get. Let's do it here. Let's do it here. 5/8. Well, 10/8s are 80. If you add 16 more to it, 80. If you add 16 more to it, we get 96. So this is 10/8s, and these are 2/8s. So that's 12/8s. These are 10/8s. These are 2/8s, which means these are 12/8s are 96. 12/8s are 96. The reason I'm writing here is because if you're going to watch this video, you have to understand the language that I use. 12/8s are 98. So you multiply the top and bottom by 12. So bottom we get 98, or 96 rather, which is very close to 100. Not quite as close as we would like, but it's close enough. And the top we get 12 times 5, which is 60. So we can say that 5/8, so that we can say that 5/8 is approximately 60%. Approximately. But of course we know that it is exactly, if you want the exact answer, is 62.5%. That was the end of that part. Tomorrow we'll deal with the concept on the following page, which has to do with not addition and subtraction of the fraction, not adding and subtracting fraction, but rather multiplying and dividing fractions. We'll do those mixed fractions, that is, improper fraction, that is, or proper fraction for that matter. We'll do those tomorrow, okay? Bye now.